Hi, everyone, and welcome to Karma Insights. I'm really excited to introduce you to Alper. Alper is a friend of mine and a former colleague. And today we're going to be talking about AI and decision making in government and a little bit in the private sector as well. We're going to be talking about some of those large themes of how to look at AI and machine learning and causal inference. And by the end of this conversation, I hope everyone feels a little bit more educated with how to think about this space and what it means for the next 5 to 10 years. And so I'll give Alper here a chance just to share a little bit about himself, and then we'll jump into our discussion.
That's great. Yeah, thanks for having me on, Christian. It's nice to see you again. I do miss the days that we did work together. Christian and I worked about 3 years together on various different projects for the public sector. I just graduated. did leave that position to go back to school, and I just graduated from UCLA's Master of Quantitative Economics. And then with that program, I've been diving into AI and machine learning and how it relates to the public sector, but also how it relates to helping businesses make decisions and become more data driven. And so now it's always a pleasure to look to the future and look forward to more opportunities.
Thanks, Alper. So, Alper, my general view of decision making over the past 10 years has been that we have been creating a lot of data, and organizations in the public sector and even the private sector have been trying to get better and better at using that data to make decisions.
Hmm.
A lot of times I find that it doesn't actually happen that way. You can make data say a lot of different things, and you can actually have a really good answer, but that's not the answer people want to hear.
Yeah.
And so why don't we just jump in here, and I'll give us a lay of the land in terms of AI, machine learning, causal inference, and the public sector. How are you thinking about it?
Yeah. Like you said, there's lies, damn lies, and statistics. And it's especially back in what we always knew about statistics, very easy to tell the story you want to tell. But I think the promise or the benefit of AI, and we'll really dive into that as we get along, I think, in this conversation, is allowing, with AI, allowing non technical people to get involved in the usage of data. And so the stakeholders that needed to learn the message, they're actually involved with getting into that story and getting the answer that they really need.
Okay, got it.
Yeah,
So when you look at, let's focus on the public sector for right now.
sure.
When you look at the public sector, what challenges do you see with the public sector adopting AI?
Yeah, so the public sector is definitely they have their own uniquenesses, and when I think about AI in the public sector, the first concern I can think of is privacy. The public sector has a lot of data that requires high security. This data contains information about the people that live in our communities and their lives. So it makes sense for the public sector departments and public sector departments to be skeptical about their information going to a cloud server to be computed and then receiving their output. And so on-prem or on-premise, which essentially means that the AI model is downloaded and installed locally with the coordination of the IT department, is the path forward. So basically, a company with an AI solution will provide the software and the instructions to install it locally. The organization that's receiving the on-prem AI solution, they should have the proper GPU, but here proper is really dependent on the organization's AI requirements. For simpler tasks, like translation is considered a simpler task, an ordinary gaming level GPU will do. Some tiny tasks can even run on a CPU. And obviously for really complex tasks, you need what I do know is that hardware requirement isn't really necessarily a big limitation, which might be another challenge for the public sector, because many of these AI solution companies offer what they call a turnkey solution, which means that they provide the complete end-to-end system and they give the organization the hardware, the software, and the instructions. They say, put this into your system and you're good to go. That is a big tangent, but the point I'm really trying to make isn't about the procedure about AI departments, the procedure that they take. My point is that with an on-prem solution, when a user inputs their information to an AI model or for an AI model to process, it's simply sent to a local server. So the privacy concern goes away. And this,
Uh, Let me ask this though, and
yeah.
put this out there. It's like there's this on-prem aspect of it, and then there's of course cloud-based AI solutions
Mhm.
where the data is sectioned off, as well as whether the queries are being fed back into the model. Can you explain a little bit more about how organizations should be thinking about that?
What do you mean? Can you explain a little?
Let's say someone is using Azure and you have OpenAI built into Azure, right?
Right,
Technically, they already have their data in Azure with a lot of different Asian organizations.
right.
And if they started using OpenAI or even Meta's Llama model,
Uh-huh.
do you think that takes care of the privacy concerns?
Again, those are cloud-based. For me, it always helps to think of AI models like the classic linear formula we learned in middle school, which was y equals mx plus b. And if you remember, m was the slope, x was the input, y was the output. And this is a very simplified version of how the LMs work. When OpenAI, DeepSeek, or Meta announced that their models, and they talk about their size and these parameters, they're talking about the number of m's, basically the slopes. And they're basically, so these models are basically huge equations. So when you write something into ChatGPT, this is the X you put in, and then the ChatGPT or OpenAI's model, as like their new O3 model, it will read those words as numbers, input them into the formula with a bunch of those M parameters, which is like M analogous to M multiplying X, and then it'll give a response. This is the output, the Y. So in a cloud server, this computation, this formula, and producing that Y happens in a cloud server and gets sent to something that is not local, not on the premise. But public sectors have that privacy concern, and they don't want their information going to that other computer, that other server, and they'd rather have that calculation, the y equals mx plus b calculation happening locally.
Got it. Okay, now we might get technical here for a second, but I want to go into this a little bit
Yeah.
because, like, the thing that I'm seeing a lot of, it's like whether it's Salesforce, Workday, or Microsoft,
Mm-hmm.
they're all building out agents and models in their software.
Right.
So if an organization is using, my perspective is the data is already in the cloud. They're using the model. Yes, the computation is being done in the cloud,
Mm-hmm.
but their data is not being fed into the model to improve it or going out of the model because it's just equations and numbers. So that's why my perception was the privacy concerns are, it's not even the normal way of looking at privacy even.
So that's
Because it's not like
interesting.
you're giving the data over, you're giving numbers over. Tell me, how should I think of that?
I think you're going into two things. So one is privacy, and public sector organizations, they will feel more uncomfortable with their information going to a cloud server. But companies like OpenAI, they do offer systems and packages where the data is supposed to be more secured. But
Sure.
public sectors might be just a little more hesitant behaviorally. The other item you're going into is fine tuning. It sounds like there's like a hesitancy of the large language model being a generalist. And so when you put an input, or you put in a prompt into ChatGPT or a large language model, and you get something back, it's a not so smart expert on everything. But certain companies or public sectors would want a little bit of a subject matter expertise or a domain expertise. And I'm happy to get into more of that. But essentially what that means is if the pre-trained model has those, let's say it's just the simple one, y equals mx plus b, in the pre-trained model, m has the value of, let's say, 5. Then you can throw in more data for it to get trained on, and that then fine-tunes the model a little bit. So now M becomes 5.1, 5.2.
Okay. Got it. Yeah, that makes a lot of sense.
Yeah.
Okay. Can you what role does retrieval augmented generation or RAG play in overcoming some of these challenges that we're talking about here?
Yeah,
And if you can
definitely.
explain RAG as well, just for everyone to understand it a bit better.
Yeah, definitely. So RAG is an exciting new, and it helps with this. It's a solution that does satisfy in terms of the public sector and their challenges of having something on-prem so that it's cheaper and more private. Another concern or challenge that comes with the public sector is that possibly the data is not very well organized. So one exciting advancement of these retrieval-augmented generation or RAG models is that this model bypasses the possible unorganized data pipelines in the public sector. First and foremost, I'm sure that on ChatGPT, for example, you can actually create your own RAG model, but it's still quite manual. You have to go set it up yourself. But one common example is from academia, and you have a bunch of papers and you need to synthesize them into a presentation. You can upload these papers, let's say as like a PDF form, and then ask ChatGPT to create a slide deck and a full presentation. It'll write out the language that you need on the slides as well as the speaker notes. It can find formulas or the charts in the paper so you can reference them. It'll understand them. So you ask ChatGPT to, and I'm saying that it can find the formulas or the charts in the paper, understand them, and suggest which slides to put them on. That process is still quite manual, like I said. So when an AI company that offers a RAG solution integrates their solution on-prem for an organization, the RAG model is able to look through that organization's internal data and provide a result that is based on the internal information rather than that generalist knowledge that classic LLMs have from the internet. This way, you have an LLM that has the full extent of the organization's contextual knowledge. You and I remember we all love that client, and we even try to be that one person on the team that knows everything about the company or everything about the organization. Is that person that we can feel like we can go to with any questions. How does this work? What does this person do? Who makes this decision? That's where this retrieval part comes in. So now you have an LLM that goes through your organization's data and retrieves relevant information and then uses that information to craft a response. For example, if a client has a question about their budget, they can ask the model which vendor is charging me the most per month, and the RAG model will locate the right table of that information, quote unquote, read it and understand it, and then return the answer to your question. The way the solution bypasses the possible situation in which the public sector's data isn't very organized is that these RAG solutions just need access to the data. The files don't have to be super organized or a particular type or a particular form. All the data that the organization wants the model to access just needs to be dumped in what's called a data swamp. There are lakes, puddles, ponds, etc. Now there are data swamps because it's more of a hodgepodge of everything. You can throw in all sorts of data types, PDFs, PowerPoint slides, Word docs, CSVs, and the RAG solution will sort through the data, clean it itself, and so it can access and retrieve the correct information. So one last item on my mind is that one big beneficial use case of RAG for the public sector especially is that it helps organize their information by creating a single source of truth. You and I have both been on projects where information on the same topic or the same information is stored in different places. And then there's this internal confusion on where to routinely or systematically go to access this specific information. With a RAG model, organizations can ask the model where there are discrepancies on certain subjects and even create consolidated documentation. Suppose an education department has similar information on class size regulations or handicap accommodations stored in different places. The RAG model will pull or retrieve from all those places and even create a consolidated report on everything this department knows about the subject. You can do this for every topic, policies, etc., that pertain to your organizations and create a collection of almost encyclopedic articles. So anyone in the organization knows exactly where to go to, how to find the information they need. And it's this convenient, easy to use single source of truth.
Yeah. I suppose I'll push back a little bit or ask some questions there of if there's conflicting information in a swamp, then fundamentally it'll probably say it's either this or that. And so you don't get away from cleaning your data, is my point there at some level. You do still have to, at some level, there has to be data cleaning where someone's going to have to say what is the right answer.
Right. So you do have to, it informs you where there's a discrepancy. And so at the end of the day, it's your decision on what's the right one. But what it can do is based on what it's pre-trained on and based on how much of each, let's say, side of the argument it has information on, it can suggest to you, this seems to be the right decision. And then it can even lay out pros and cons of each one's. And it's as if you're chatting with the person that knows everything. And that's the other benefit of RAG is that it's super interactable. So someone doesn't have to know how to scroll through a bunch of Excel spreadsheets of trackers and read through a bunch of reports. They can just pretend like they're talking to someone or chatting with someone.
Yeah. And maybe we'll get a chance to talk about this, but I've been thinking about this separate idea around AI. And even at Karma Advisory, we've thought about how to use and leverage AI in a way that makes sense of like, how does this impact, and we can talk about this later, but the
Yeah.
question I'll put, and then we can talk about it later, is like, how does this impact how we as individuals analyze and understand topics?
Topics.
And
Yeah.
just any issue at hand, because my theory is this, is that the hard work of not understanding something,
Yeah.
it's hard work for a reason,
Yeah.
and it gives our brain time to create mental models
Mm-hmm.
on how to bring the pieces together.
Right.
And the question I have is like, all right, so now that we have amazing AI models that can help speed up the collection of information, now how fast can we create that model in our head so we don't have to use the AI model to have a conversation on a topic,
Totally.
right?
Totally.
And I still think about that with writing, with analysis, where you can see numbers and have an intuitive sense because you know what those numbers mean when you look at them or things
Mm-hmm.
like this. Anyway,
Yeah.
if you want to chime in a
If you
little.
remember, I'm sure the first thing we did every time we went on a project was we had the get smart process, right? We would have to get smart on and create these get smart decks and make sure that we understood the context of what was going on in that project. And a lot of that was interviewing the client, getting the information, understanding what the problem was. With RAG, you already have someone that's smart. So if we have
Sure.
questions about the context of a project and being able to immediately jump in and have those conversations of how do we move forward with our clients, RAG is the tool that allows us to get there. And then on top of that, that's where agentic AI comes in. So now, yeah, which we can
Let's chat
go
about that
into.
now.
Yeah.
Yeah.
Yeah, the other advancement in AI, which is beneficial for public sectors, as we were talking about, is this agentic AI, and this is basically just where AI does the work. And what I mean by that is a lot of people, let's say we're talking about this RAG system or just a large language model, and we need to understand the lay of the land of this new project we're on, and we want to be able to land with our feet running and the tires turning. Large language models, they produce the language we need, or let's say you're trying to code something, they produce the code you need. But then we have to copy and paste the code to run it in a local terminal, or we need to take that language and make our own PowerPoint slides. Now with agentic AI, the AI will actually execute the task. So you don't need to copy and paste or anything like that. And so you can just say the RAG technology will retrieve the relevant information. Let's say we're making a Get Smart deck. And then the agentic, the AI agent, will create the deck. So you can imagine what happens when you combine the value of RAG and agentic AI. You could ask for dashboards, tables, reports. And like I said, the RAG tech will retrieve, then the AI agent will not just return instructions and suggestions or code to create those things, but it'll actually create those things itself. Yeah. Yeah.
Let's go into this a little bit
Mm-hmm.
because I think it's like a really topic and idea. And I'll put the background here to say this.
Mm-hmm.
I think we've gone through, I recall a time where, I'll put it this way. I remember in 2015, people talking about AI and saying it's the end of radiology. And that was like this was the articles that would be posted on
Right.
LinkedIn and the internet. And I think largely, and my sister was actually a radiologist, and I've talked to her about this, and her kind of comment was that it hasn't dramatically changed her work at
Mm-hmm.
all. What it has done, though, is been leveraged in very specific use cases to make to enable them to react faster.
Mm-hmm.
So one really great example she gave me was that in the hospital, scans are always occurring,
Mm-hmm.
right? But the hard thing is it's a giant list. And as a radiologist, you don't know what the priority is. And so now they have AI models that are doing the pre-reads of the scans and saying,
Yeah.
okay, this is an emergency.
Mm-hmm.
This one is not an emergency. And it might not be 100% correct, but it at least prioritizes them.
Exactly.
So that way they can look at the most important one. And I think that's a really good example of basically an agent. It's automatic. It's not like a chat interface even.
Mm-hmm.
It's literally just a bot that's doing an analysis. It doesn't have I'm sure there's some level of, there are probably some business rules built into it to say, if it is a head trauma, it's emergency, it's an emergency. And so that way they can codify some pieces of it
Mm-hmm.
and say, if you find X, then it's urgent or whatnot. If you find that it's a broken leg, it's not as urgent as a head trauma. But I thought that was a good example of, I guess sometimes I think the idea of agents is oversimplified to look at a replacement of
Yeah.
roles and responsibilities rather than either an enhancement or of a role or pieces of a role
Yeah.
that would change. What thoughts,
Yeah.
comments on?
One part of that is it goes back to what you were saying about lies, damn lies, and statistics. And so when you have a team that's responsible for creating the data story to be able to help with the decision, there's a possibility of the stakeholder who's receiving that information, receiving information and in a way that might bias or influence a certain lane, right? And so now, let's say with the radiology, with AI, what I was saying before was now you have the non-technical person or person with the let's say in this case, data analyst expertise in the driver's seat. So now your sister gets to decide what reports are made, what information is on them. Agents can create the data sets that you need, can do the tracking, can create all the different tables and dashboards that are dynamic, let's say, also doing the pre-screening radiology scans, let's say, to help with that. The other aspect of it, when I say it's not, or when you augmenting rather than replacing, is we can also think about the hospitals, carrying on the same example, that are understaffed. They don't have there not necessary amount of doctors to look at these scans and make those decisions or have enough of a human intuition aspect to it. And they could do a lot more work if there's an AI that helps with the initial parts of it. And so they're able to screen, they're able to look at more patients. And so it's
Yeah.
more about allowing patients not to be sent to other hospitals, but maybe if these understaffed, under-resourced hospitals can be a little bit more self-sufficient. And that's something that we can continue talking about as we get along this conversation, but getting away of the fear of replacing jobs, but actually using AI to democratize.
Yeah. Interesting. So let's talk about this for a second. Let's talk about causal inference.
Yeah.
And why is that important for policy decision making?
Yeah. So the belief that, so I mean, going back to the belief that self-sufficiency can play even the playing fields, that was a big motivation for me to go back to school and attend UCLA's quantitative economics program. And so over my time in development policy classes or working with the public sector, I've definitely seen that causal inference is something unique about the public sector, or many others. Obviously, marketing has that. Obviously, the medical field as well. But just from my experience, I've seen how much importance there is when it comes to coming up with and running development programs. There needs to be evidence that they work, or needs to be an evaluation of whether it worked. And simple correlations don't really cut it. They don't answer those kinds of questions. We need to know if there were a certain intervention that really caused a change in this outcome so we can decide whether or not to deploy it.
Yeah. And I would, and I'll argue on this one for a second, or not argue, but
Mm-hmm.
say it's like that idea is everywhere. It's like you do something, is it going to give you the outcome you expect? Clearly, public sector and policy and healthcare and education are different in the sense of these are people's lives that you have, that you're kind
Right.
of, that you are impacting by these decisions,
Mm-hmm.
right? And but that being the same thing occurs in the private sector
Definitely.
as well, for certain. It's, and a lot of organizations can't take chances on decision making. So anything, the way that I tend to look at this kind of stuff is that, like, it's about reducing the risk around a decision.
Mm-hmm.
And if AI can help you, one, make sure you're thinking about all the considerations. That's in and of itself, that's a helpful
Mm-hmm.
utility,
Mm-hmm.
right? Because there's the known unknowns and there's the known knowns, but then you can't know the things that you don't know, you
Right.
know? And I think that AI has a really good place to play there because it has such a large data set to say, actually, you haven't seen what actually can happen when you implement XYZ idea,
Right.
right?
Right.
I wish I could give a good example, but it's like, what's the impact of building a park right under the bridge?
Mm-hmm.
The pros, the cons. here's what's happened all around the world
Yeah.
based on the demographics, based on the climate, etc. These are decisions that local governments have to make all the time. Where are they going to build something? Where are they going to put something? What impact will that have on the population, land values, all these things, right? Could we talk? This is getting a little bit detailed here, but there's causation, there's random controlled trials, there's double machine learning. Like, just a quick overview of what these things are. And the reason I ask these things to you, Alper, is not necessarily, not all of it's groundbreaking, but I fundamentally believe that what is happening here is all, and this is like a way oversimplification potentially, but let's say in the 80s and 90s, everyone was starting to use Excel and Word, and we're like, whoa, this is a game changer. And now we're all saying, all right, let's use AI. But if you don't understand causation, random control trials, double machine learning, if you don't understand some of the technical aspects, then you can't be as an effective user of these things. Now, that's my hypothesis, but I have a math, statistics, and economics and computer science like background and a love of that stuff. And so I value it, but not everyone necessarily does. So explain those things and why are they relevant?
Yeah. So the first thing we can talk about is like causation in different industries. And a lot of industries in the private sector they have the privilege of being more focused on prediction rather than the actual interaction or the relationship between two variables. And so that was an initial limitation of using machine learning for causal inference, because there's this black box or under the hood problem where you don't know what exactly that relationship is. Machine learning does a good job at modeling real life systems, because real life systems are very complex, they're very nonlinear, but you don't really know what's going on under that box. And so that's why when it comes to policy evaluation, there's still these usages of statistical analyses that aren't as nonlinear and complex. And so that's where one big innovation, that's where RCTs came in, which was a big innovation in the field of development policy. And it was really honed in and taken very far by these two development economists at MIT, Abhijit Banerjee and Esther Duflo. They took advantage of natural randomized experience, let's say lottery-based policies, and they also ran their own randomized control trials on policies, similar to how they do in medical trials, to try to isolate that causal relationship. And they even won a Nobel Prize for it. And I did, in fact, complete their MicroMaster program from MIT during COVID. I'm happy to talk a little bit more on how RCTs lead to double machine learning. But unless you have a question you want to.
Yeah, let's go over it. I love this idea of counterfactual outcomes,
Yeah.
and really trying to, if you can explain that, just give it a high level overview so
Yeah.
folks can start to get understanding of that language.
Yeah, definitely. The reason these RCTs work is that by randomizing your control and treatment groups, you're making the average baseline of each of these groups the exact same. The only thing that's different is whether there was a treatment by the policy intervention, let's just say. So another way to think about this is you're creating that counterfactual parallel universe for each person, and you're experimenting what would happen to you in that parallel universe had you been or not been treated. And you basically have another version of yourself where everything about the two of you is the exact same except for that one treatment.
One thing. Yeah.
And therefore, the difference between those two people is the causal effect of that treatment. Now, running these experiments requires a lot of organization and effort, but one focus of the UCLA's MQE is teasing out that effect with machine learning or AI. And the way it's done is taking advantage of AI's complex nonlinear predictability that I mentioned before when discussing the black box problem. And you use that to predict the outcome in that counterfactual parallel universe. So that way you're essentially creating a parallel universe so that you can isolate for only a change in that treatment. And since you're using machine learning to model that nonlinear system, the result you get for that causal impact on the same data is more accurate than the standard methods. Every interaction and relationship between the factors in our lives is highly nonlinear. So if you can use AI and machine learning's nonlinear predictive power to tease out that causal effect, then it's much, much better. And this methodology is called double machine learning, like you mentioned. And if people are interested in learning more that are listening to this, my thesis advisor, Denis Chetverikov, he's a pioneer of this, and they can absolutely check out his work.
Oh, awesome.
Yeah.
So I want to jump forward here a little bit, Alper,
Yeah.
okay? If we were to look at the future of AI
hmm
and driven public policy, what do you see if 10 years from now, 15 years from now,
Yeah.
we're looking at AI and we're saying, here's how it really changed government, public policy?
hmm
What would you say that is?
Yes.
What's your
I
hypothesis?
mean, one I can say I can frame it as a hypothesis and a vision. I can also frame it as more of a hope.
Yeah.
So one hypothesis is that let me just charge this. There is a problem with RCTs in how it's been done and what they got Nobel Prizes for. And Bill Easterly, who's a former professor of mine at NYU, pointed out this flaw in them, that RCTs are really good in their micro settings, but their external validity rate is not good. External validity, what I mean by that is basically testing whether an experiment done in one setting will have the same result in another setting. So if you have a RCT or a test from one small town, when you do it in a completely different small town or a school in a small town, the same experiment in a different setting, in a 2015 paper by Vivalt, it was shown that the average difference between an economic RCT result for one setting versus another is 114%. In medical literature, this difference is only, or in general, these differences are only 5%. So they don't,
Wow.
and that's a huge, you can't trust it in a macro setting. And so Easterly argues that they don't answer these macro scale questions. And
100%, right?
yeah,
If
exactly.
you want there to be a far more strong correlation, right?
Yeah.
Otherwise, what are you doing? You're just putting your thumb,
You see a result somewhere else and you can't really trust that it's going to work for you. Now, I could argue that tools like double machine learning allow us to gain RCT's benefit for
so,
estimating the parallel universe for very large scale questions. But the other argument that I think I want to make that I believe more in is that with AI agents, RAG systems, and double machine learning, the capital and human capital barriers are removed. And so local governments can become more self-sufficient, and it'll be easier for local governments to analyze these causal relationships to help with their data-driven policy. Double machine learning replicates the essential benefit of an RCT by predicting that counterfactual universe. So you don't need to design, plan, manage, organize an entire experiment on people. That's what I mean by removing the capital and human capital barriers. Now, you do need the right variation in your data, or maybe the best case scenario is some natural experiments to train the model so that you can predict the counterfactual. What can help you locate that data or that kind of information from your internal system is RAG models. And if you
sure.
don't have an analyst that can use the double machine learning functions on Python to train and run them, don't worry, because your AI agent can do that for you. So back to my original point. RCTs, they're good for micro level policy questions, but not for macro level ones. Our RCT results for a local setting are strong because they're better targeted. That way, if more and more local governments are empowered by all these AI and machine learning tools to find their local solutions that are tailored to their local circumstances, with the capital and human capital constraints taken away, then you can think about the aggregation, and the aggregation of these micro solutions could lead to macro level change.
Yeah.
So that's the more realistic hypothesis, but I can also get into the vision, the more hopeful vision.
Look, I'm going to give a random example,
All right.
okay? And I think this is potentially helpful, and you tell me if I'm right here, okay? If you use like a wealth management company like Vanguard or Fidelity or something like that, and you want them to, they'll have this question there that'll say, when can I retire?
hmm
And they're basically taking your data, your age, and then they're putting out a Monte Carlo simulation usually
Mm,
to try to say, all right, you're likely on this band to say that this is going to occur. And I think that that might be the same way to start looking at a lot of this stuff, where you're
yeah.
basically saying, let's say we've created a digital twin of a city, like where all that data is in one place. And you can say, if I do X, what impact will that have on everything or
Exactly.
one specific thing? And that's fascinating, right?
Definitely.
Now, I'm going to argue, though, for a second here. It The data and the insights are interesting. The challenge always is how to operationalize said insights.
Definitely.
And I think, and that's that's the thing that I think a lot about these. And look, don't get me wrong, agents and all of that will probably help in
Yeah.
some ways,
Yeah.
but like you still have to do the hard work of mobilizing on these initiatives to do something. It's not like the work goes away. If
Absolutely.
anything, I think the velocity actually increases because now you're like, let's say an analysis for a city was 1 year to figure out how do we improve broadband penetration in a city?
Mm-hmm.
Like, how do we get telecom vendors to create more fiber optic networks across the city's footprint, right?
Yeah.
Let's say that analysis used to take, I don't know, 9 months to a year.
Right.
And if that could take 3 months and then everything is taking 3 months, that changes everything from decision making to budget cycles to staffing.
Mm-hmm.
It's a different world, frankly,
Right.
is how I think about it, at
Yeah.
least.
One fear that I hear is AI gonna make our jobs easier, or is it gonna give us a higher expectation of how much work we have to fit in and complete by the end of the day, or if we're talking about these big projects, how much work we need to fit in by the end of the year. And obviously, you're preaching to the choir. We've been in these whiteboarding sessions and in these rooms together where we know what the right answer is, what the right recommendation is for our clients. But now it's a matter of managing personalities and telling and giving that decision or giving that recommendation in a way that'll actually persuade the clients that we have. And so I totally agree. And in fact, people might be able to use AI agents to create reports that benefit their perspective, and the debate necessarily doesn't go away right away just because of
Yeah, yeah, yeah,
managing
that's right.
personalities. But I do really appreciate what you said about where this can take us in terms of what's the hypothetical scenario and outcome of this policy. And so that's really the foundational piece that inspires these ideas. It's it's the belief that there's this, to me, it feels like a golden opportunity for public policy to become more data driven rather than belief based. And if the data we have available in our public sector organizations can be better leveraged, we can have more objective answers and solutions rather than subjective. And I know this goes against what I just said about arguing, even though you have these agents, but hopefully, the dream is that there is a more objective focus on what the right solutions are. The ideal world I see for a modernized public sector is the ability, like you said, to model our local and maybe even macro societies. Then we can assess how changes in some factors cause changes in certain outcomes. Um, and this is basically just repeating what you said, but one way I conceptualize, and I think the best way that I, at least the way I can understand what I'm saying, is that I is imagining the dials that controlled the audio settings in an old car. And by old car, I really just mean a car from like the late 90s. I'm sure you remember in those cars, you have the dials to adjust the levels of the bass, the treble, etc. So imagine you're sitting in an audio engineer room and you have hundreds of these dials. And if you play with just one of them, you can immediately hear the difference in the sound of the music playing. So let's say our outcomes, instead of the sound of a song, are metrics in our living standards. If you increase the bass, you can hear how it changes the sound of the song. And that's the isolated impact of more bass. So now change both the bass and the treble, and it sounds a little different. And that's the isolated impact of increasing both of them to a certain degree. Now, with our model of our society, let's say we turn some dials that represent certain policy initiatives. And as you turn dials, you can see live how our living standard metrics change. Um, with these dials, you're creating all these parallel universes and comparing them to each other. You can choose to only change specific dials to tease out their isolated impact. And each local government could have a tool like this. In fact, with RAG, fine-tuned models, or AI agents, they would easily be able to create, maybe hopefully one day, a tool like this. And so then with methodologies similar to double machine learning, this tool could use AI to predict the outcome of a certain combination of factors adjusted by the dials. And it would make policy decisions much more objective. And with the dials, it again removes that human capital barrier. Someone just needs to know how to change the dials. Obviously, I don't want to get into the other side of policy that we've alluded to a little bit. People might have personal reasons for a certain policy decision. But if you imagine we're talking about taxes, this advanced model would show us exactly the pros and cons of different tax rates or tax policies and the
Yeah.
effects and externalities these different tax rates would have.
Yeah. I think that like there's two things that I think about here, and I know we got to just wrap up in a second here,
Yeah.
but is one is this idea of a lot more analysis is likely going to occur on things, and a lot more decisions will need to be made,
Mm-hmm.
right? And everyone is going to have to understand how these models work more so they trust them when it outputs information,
Yeah.
because based on the data inputted or the model, folks can be questioning things, of course. And so at some level, discernment and wisdom and action are still extremely important. And it's so I think that's like the exciting thing about this is that in some odd way, I think about this, Alper, is that we're not fundamentally, we're just putting everything on fast forward, right? Like we're not, you're just going a little bit faster, and the dial by which we're analyzing, making decisions is changing. But at the end of the day, you still need wisdom and discernment. And that's it. In some ways, I think that's a wonderful thing to remember here. It's like there's wisdom and discernment. There's going to be issues. There's going to be complexities. It's not like statistically significant findings in the past
Mm-hmm.
always made sure people would go in a certain direction. And those statistically significant findings weren't always actually 100% correct because the data that went into them wasn't always totally
Absolutely.
there, right?
Absolutely.
So like you have so much nuance and it's so rich to think about like how we're all going to work with this stuff in the future.
I agree. I totally agree. That's one aspect of it that I think that it's important to remember, that one perspective that you can look at this, and I don't want to take away from the fear of jobs being replaced and people
Yeah.
not needing to do their job function because it's replaced. But it's really more about enhancing what we're able to do, especially for the kinds of teams that don't have access to that kind of technical ability. And
Yeah.
so if there are local governments that otherwise weren't able to create certain kind of dashboards or become data driven or have this kind of objective policy making, now they're on an even playing field. And the reason that's important is not only can they make decisions that are best for themselves, but everywhere, every local government can make the decisions and analyze their own policy as best for their own micro setting. So it's custom solutions.
Yeah,
So yeah,
totally.
exactly.
Alper, I've so enjoyed this discussion. I'm glad we had a chance to chat about this, and thank you for taking the time.
Yeah, no,
Appreciate it.
I really appreciate you having me. It's always a pleasure for me to try to get out some beliefs in the sense of getting rid of belief-based policies and more data-driven and have data-driven policy insights. Maybe some of the things that we talked about are ideological, more than a hope than a vision,
Yeah.
but it's also good to help, talk about self-sufficiency with AI rather than what's scary about it and learn more about it as in how it affects other industries. So I really appreciate you having me
Yeah.
on.
Thanks, Alper.
Yeah, thanks.
All right. I'll talk to you. Take care. Bye.
So, yeah.